Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
I
love that word.
Hello and welcome to Diffusion. Sit back and relax while we inject weird and wonderful science directly into your brain. I'm Ian Woolf. On this edition, new contributor Barry McKay talks with Phil Hore about dinosaurs in Australia. But first up, here's the news. CSIRO finally allowed to do science? When CEO Larry Marshall was appointed in 2013, he declared that Australia's flagship scientific research organisation CSIRO would no longer engage in the public good science required by its charter, but only do research that could directly develop a profit for the organisation. The focus of the Commonwealth Scientific and Industrial Research Organisation should be not doing science for science sake. He fired 1,500 people. Marshall stopped research into climate change with the justification that it was no longer time to gather knowledge, but a time to learn how to adapt to climate change. Where the money is. Last week, newly appointed Science Minister Greg Hunt wrote a statement of expectations to order the CSIRO to reinstate public good research as a priority, and for the CSIRO to return to research into climate science by hiring 15 new people. Too late for the 1,500 staff that have been fired and need to find new work. Unfortunately, very little of the funding has been restored, which makes it impossible to implement. In 2013, the Liberal National Party's Abbott Turnbull government appointed venture capitalist Larry Marshall as CEO and businessman David Thodey as chairman of the board, instead of scientists who had traditionally run the scientific research organisation. Larry Marshall famously won the Bent Spoon Award from the Australian Skeptics for insisting that water dividing should be investigated by taxpayer-funded scientists. Under Larry Marshall's direction, quoting in his message as the government's jobs and growth priority, the CSIRO have sacked more than 1,500 people, including most of their climate scientists, and all of their support staff, so that the scientists are also the cleaners and replaced public good science with research for private cash. The Bureau of Meteorology had to step in and save some of the jobs as Marshall didn't know or care that climate modelling is essential for weather forecasting, which all Australian farmers and businesses rely on. Larry Marshall also stated that the 67-year-old government institution would be run as a startup business, and that all its scientists were to think of themselves as entrepreneurs. He started a startup accelerator program within CSIRO called Acceleration, with an emphasis on the on, to help push scientists out of their research and into running a company to commercialise their previous research results, which has the side effect of halting them from doing any future research. At least 9 out of 10 startup businesses fail, which seems too high a price to pay for both the scientists and the public. Larry Marshall famously sacked world-renowned sea-level expert John Church while Dr. Church was on a ship heading to Antarctica to measure effects of global warming. The same CSIRO Antarctic research ship was then hired out to international oil companies BP and Chevron to prospect for more oil and gas deposits, causing more global warming. In 2015, the then Federal Minister for Science, Ian Macfarlane, wrote a statement of expectations to the CSIRO. He stated that the policy priorities were agriculture, mining, medicine, oil, gas and coal, manufacturing, and to maximise the return on investment in funding by the government. Greg Hunt's statement of expectations, in contrast, states the exact same priorities, but adds climate change, environmental technology, whatever that is, and big data. Where the previous Science Minister cut education as one of CSIRO's core functions, directly contradicting its charter, Greg Hunt expects that they promote science, technology, engineering and maths, STEM education. Now, quite apart from what the difference is between technology and engineering, it's a bit hard to do this after you cut the education budget and sacked all the staff. Federal Minister Hunt expects open access to publicly funded science, except where it contradicts making money from publishing the research. Mr. Hunt wants the CSIRO to be supporting the nation's future science and research capability through ongoing horizon scanning or foresighting activities. But without a budget, I foresee difficulties. Science Minister Hunt promises 15 new climate scientists hired and $37 million climate research funding over 10 years, a fraction of what was cut both in people and funding. It is good to hear the new Science Minister declare that climate research should be part of CSIRO's core activities and putting a little of the money that was cut back in. However, it's very little and it's a little late. Scientists don't just sit in a cupboard waiting to be powered up. They have to find work to pay the bills, and many people have moved to new jobs, some overseas. Certainly, any feeling of job security at CSIRO is gone. Science can't be stopped and started this way either, as much of the expertise is built up over the decades of senior researchers' careers in teams, and when you start cheap and young, you miss the expertise and wisdom, and just the knowledge and vision of the projects. I hope to see funding for astronomy, computing and education by CSIRO to be restored so that the new Science Minister's good intentions become possible. But will Greg Hunt put his money where his mouth is? You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. Over the next few weeks, we're going to look at the discovery of a new dinosaur here in Australia called Savanosaurus. The dinosaur was first discovered in outback Queensland near Winton in 2005 by the director of the Australian Age of Dinosaurs Museum in Winton, David Elliott. In October 2016, an academic paper was published in the journal Nature by Dr. Stephen Poropat, announcing the new species of dinosaur to the world. In this edition, we're going to hear from Phil Hore, tour guide and dinosaur expert at the National Dinosaur Museum in Canberra, with a bit of background on Savanosaurus and a little bit about Australia during the Cretaceous era in which Savanosaurus lived. A warm welcome to first-time contributor to Diffusion, Barry McKay. Barry is a freelance journalist who works with Deutsche Welle Radio. Barry spoke with Phil Hore in Canberra. There are a few occasional noises in the background. I don't think they're baby dinosaurs.
So first off, what is a sauropod?
Well, a sauropod is a dinosaur that's bizarrely related to the carnivorous dinosaurs like T-Rex, and they were large, four-legged animals with long necks and long tails. That's probably the easiest way to explain them. And they lived all over the world, including Australia, and they went from quite small animals to the largest animals that ever lived.
Do we have any particular famous examples of any sauropods?
Well, most people would probably understand Brontosaurus, and they grew up with Brontosaurus, and Brachiosaurus if they saw Jurassic Park. And Australia has a few of their own which aren't very well known, but hopefully we'll start to change that. But yeah, so Brontosaurus is probably the most famous.
So what were the typical characteristics of a sauropod?
The typical characteristics are very long necks, very long tails, enormous size, and very tiny heads with very primitive teeth. Their teeth were they didn't connect together. They were kind of lots of gaps between them and things, and that's because of the way they chewed. They ate their food in a lot different way to most mammals do today.
And because the heads were so tiny, does that mean they had a very small brain?
Almost all dinosaurs had small brains, but if you want to imagine the size of a sauropod's brain, if you look at your thumb, most sauropod brains are about the size of your thumb. So these were very small-brained animals.
Why did they have such a small brain?
They weren't doing a lot of thinking. Like if you're a sauropod, you're basically looking for something to eat, looking to not get eaten by something, and looking to mate, and that's about your day.
What did the sauropods eat?
Most of them would have been eating plants, definitely not flowers. Flowers hadn't evolved during most of the dinosaur age, and certainly not grass. Grass didn't evolve until much later, so they would have been eating things like ferns, tree ferns, conifers, pine cones, things like that.
Where did sauropods live? What sort of habitats did they live in?
Well, that's why you get so many different sorts of sauropods. Some of them had necks like giraffes heading straight up. Others had necks that stretched right out in front of them, and that tells us that they were all eating from very specific types of plants. So the tall ones were obviously eating from the soft plants that were at the very tops of trees. The ones with their necks straight out were probably eating from bushes and low-lying branches and things like that. And so they're all eating plants, but there isn't a single type of plant for all sauropods. They're all eating from different sorts of plants.
What habitats would suit a sauropod best?
Open area would certainly help them when you're that big. One of the things we try and point out is if your head's 20 feet away from your feet, it's hard to see where you're walking. So you don't want to be living in like entangled areas like dense forest, because you're just going to be tripping all the time. So, and we do find their footprints, which tell us they were living in big savanna areas like you see in Africa today.
So you wouldn't get a sauropod living in a forest or a pretty confined area?
You might get a specific sort of sauropod, but they wouldn't be like the sauropods we imagine. The ones that lived in forests like that, they would have been a much smaller species, and they may not have had such long necks. Not all sauropods had really long necks. Some of them had very short necks. So, yeah, it would have been a completely different design. But for the image we have of a sauropod, of this giant animal walking around, yeah, you don't want to be in a forest.
Okay, so looking more specifically at the newly discovered Savannosaurus, they lived in a different habitat to that's typical of most other sauropods?
I think the name might be actually highlighting the type of habitat that most of them would have lived in, which is wide open areas where lots of animals, and these things would have probably lived in herds of thousands of animals. So if you think of an animal 20 times the size of an elephant and then have 100 of those animals getting around, they're going to need a lot of space. So savanna, the wide open areas, so Savannosaurus, talking about the big wide open areas.
And I was told that the Savannosaurus liked sort of a muddy delta, river delta sort of type of terrain.
I'm not sure if that's what they would have liked all the time, because the other problem is if you're big and heavy, you don't want to be in muddy areas because you're going to sink. So that's where they were found. So maybe that's why they were found, because they drowned in that area. So maybe it's not the best place for them. But again, animals have to drink and animals have to move. So they might have been traveling from one area to the other and crossing a river or something like that, and some of them drowned. So that might be why we found those fossils there.
Savannosaurus was a particular type of sauropod, and it had very wide hips. Could you tell us a bit about that?
Savannosaurus is part of the group of dinosaurs, the sauropods called titanosaurs. And titanosaurs, one of the things that differentiates them from all the other sauropods is their really broad hips. They had very wide hips, and that's because they also had very stout legs. Their limbs were a lot thicker than everyone else's, and especially the front limbs. Bizarrely, their front limbs were much bigger than their back legs, which would have given them a real muscle look to them. So that's probably why, because you don't want to be tripping over your own feet and things. So if you've got big, broad feet with very large legs, you want to keep them slightly separated apart so you can walk around and not trip on yourself.
Was there any particular reason that we had such wide hips? Was it suited to any particular type of terrain, or do we know much about that?
Maybe not terrain, but the other thing that these dinosaurs had is they had armoured backs. They had like small scales, like a crocodile, little armoured scutes, and their tails were quite broad, so they might have had to carry a lot of weight. And now we're getting into things like how they lived, and that's a bit hard to tell from the fossils. Maybe they were living on a more mountainous area, or maybe they just travelled a lot more than others and just needed those stouter lips to carry legs to carry their weight a lot more. So that one, we're kind of into the guessing game there.
So how big is the Savannosaurus?
Savannosaurus was a mid-size titanosaur, so they're about 15 metres long, whereas the longest get up to nearly 40 metres. And they're the biggest biggest animals that ever lived. They're even bigger than a blue whale. So this one's about a mid-size sauropod.
So how did the sauropods reproduce and raise their young?
Well, when you're that big, raising your young is going to be a big problem. As I said before, if your head is 20 feet in front of your legs, you're not going to be able to see where you're stepping, especially you're not going to be seeing if you're stepping on your small children running around your legs. So it's quite possible that these dinosaurs laid their eggs like turtles. They'd lay thousands of eggs all at the same time, and then they'd walk away and just leave them alone, and those eggs would hatch, and eventually as they started to get a bit larger, they would join other groups. And that also explains how they wouldn't be that many dinosaurs, because big dinosaurs would protect their young, and if you had thousands of young sauropods growing up to be adult sauropods, they would devastate the ecosystem. So they were probably being eaten a lot, like they would have been easy prey for predators as they were young, and only a few of them would survive to adulthood, where they would join the herds of the rest of the sauropods.
So what sort of survival strategies would a very young sauropod would have had to keep alive?
Well, that's where maybe they did live in forests, because when you're small, and we're talking about things about the size of a horse, so not that small to us, but for a sauropod that's quite small, they would be able to get into heavily forested areas, and large numbers of them. Certainly a lot of them might have met a sticky end, but a lot of them would have survived that way. They would have been able to find food to eat, and then once they get too big for the forest, they'd have to leave the forest, and then probably that's when they would join a big herd.
So when did the sauropods die out and why?
Well, that's where things like Savannosaurus are very important, because in the rest of the world we're seeing that the sauropods, they died out very early on. A lot of them didn't survive into the Cretaceous period. They were a Jurassic sort of dinosaur. But in places like South America and Australia, Gondwana, they were surviving much later, and they lived right up until the very end of the dinosaur age.
Could you tell us a bit about why dinosaurs died out in general?
Well, if you count birds as being dinosaurs, then dinosaurs didn't die out. And there are more bird species today than any other animal except for insects and fish. So you could almost say we still live in a world dominated by dinosaurs. But if you're talking about the big extinction event that wiped out most of the dinosaurs, there's very good evidence that an asteroid hit the Earth about 66 million years ago. And one of the ways I like to point it out, most of these dinosaurs were big, and when you're big, there's not that many of you. So when there's a terrible thing like a bushfire or asteroid hitting, resources go, and low numbers mean that you're not going to bounce back very easily. So one way to look at it is if you look at Africa today, there might be 1 million elephants, and that's not a lot of elephants when you compare it to rodents, where there might be 100 billion trillion rodents in Africa today. So if something devastating happens to Africa and you kill 90% of the elephants are in trouble. But if you kill 90% of the rodents, there's still 100 billion rodents left, and they're going to survive that event. So when you're big, you're always very vulnerable to extinction.
With this event where the asteroid hit the Earth, how did that affect the Earth's climate that led to the extinction of dinosaurs?
Well, we find lots of things, like the immediate evidence would have been huge bushfires. When this asteroid hit, it would have thrown up a lot of material into the atmosphere, which would have then rained down red hot rock and lots of debris falling from this asteroid. And that would have just ignited forest fires everywhere. And we do find a big ash layer around that time. But for after the impact, when everything settles down, you would have had things like clouds of dust blocking the sun, and that way temperatures would have fallen. Again, most dinosaurs were very reptilian in nature, so cold weather is not good for a dinosaur. And also blocking out the sun kills the plants. So a lot of plants species would have started to die out. And when you're a giant herbivore needing to eat a lot of plants, if there's no plants around, you're going to starve as well. So it would have been a devastating impact that just for years and years, decades, even centuries, would have just had reverberating effects throughout the entire planet.
What species of sauropod are the Savannosaurus closely related to?
So they're most related to the titanosaurs, and the most important titanosaur is the biggest dinosaur we've found so far, which is Argentinosaurus, obviously found in Argentina. And Argentinosaurus was roughly around 30 to 40 meters long, so that is an animal bigger than a blue whale. These were gigantic. These were the biggest of the dinosaurs, the biggest land animals ever, and the longest animals to ever live.
How is the Savannosaurus species significant?
It's significant specifically because Australia doesn't have that many dinosaurs. So for us, any dinosaur find is very important. There were quite a few bones found, and so that's, again, a very important thing. Most dinosaurs, when they're found in Australia, we only find 1 or 2 bones. Well, we found quite a few bones of Savannosaurus. And as I said before, it's a very important species because everywhere in the world, sauropods were dying out. They just didn't exist anymore, but for some reason in Australia, they just kept going, and they survived a lot of other extinction events where sauropods died out everywhere else.
Where did sauropod dinosaurs originate?
That's a tricky one. The oldest sort of fossils that we're finding are these things called prosauropods, which look a bit like a cross between a carnivorous dinosaur and a sauropod dinosaur. And we do find fossils of those around Germany and Europe, but there is a possibility that there was one found in North Queensland in 1900, and that fossil has been under a lot of debate recently, but it's starting to look like it is a true fossil. Some person thought it was actually had been a German one. So it looks like they also lived in Australia.
So could you tell us a bit about Gondwanaland?
Gondwanaland, or you could just say Gondwana, was a collection of all the southern hemisphere continents. So Africa, Australia, Antarctica, South America, India, Madagascar. All these continents were joined together into one giant supercontinent called Gondwana. And that was going back to a time called Pangaea, when there was all the world's continents were joined together, and that was at the beginning of the dinosaur age. And then Pangaea broke up into two larger continents, and in the south we had Gondwana, and in the north we had Laurasia. And so Gondwana survived for a very long time, since almost the beginning of the dinosaur age, all the way up until only about 30 million years ago, when Australia finally separated from Antarctica.
When did the continents that made up Gondwanaland begin to split?
So India would have separated very early on, and India is so north now that you'd hardly call it a southern hemisphere continent. South America would have been one of the last ones, because it's still quite close to Antarctica, and Australia would have split about 30 million years ago. So, that sounds like a long time, but when we're talking about continental drift, and that's a very slow moving process, that's not very long at all.
Where was Australia positioned compared to today? This would have had implications for climate and habitats back then.
Very much so. So if we go back to the beginning of the formation of the Earth, Australia was the most northern continent, and we've drifted all the way down south. So by the time of the dinosaur age, Australia was the South Pole. In fact, Canberra was pretty much the South Pole at that time, and then slowly started to drift north again, and that's what we're still doing today. And we're about to run into Papua New Guinea. We travel north about 10 centimetres every year. So during the dinosaur age, we were right at the South Pole, which means very cold winters and very warm summers.
Were you getting any ice at the polar regions back then?
No, there wouldn't have been any ice, except, there might have been frosts and there might have been the occasional snowstorm or anything. But no, whenever there's polar caps, that's an ice age. So we keep thinking of the ice age as being something that was, a couple of million years ago and ended. We're still in the ice age. There's still ice on the caps. That's an ice age.
Okay. How was the Earth's climate different during the Cenomanian age of the Cretaceous period? So that was the time when the Savanosaurus lived.
Well, a way of thinking about it is if you go in the middle of any large continent today and you find deserts. So when there was a giant supercontinent like Gondwana, would have been very wet around the edges and very warm on the interior. And as it separated, it would have changed a lot. And so by the time the Cretaceous comes around, which is the final time of the dinosaurs, all the continents were starting to move into their current positions, and that was changing the environment a lot. In fact, the environment was a lot like today. Flowers were just starting to appear, and flowers changed changed everything. So yeah, at that time we would have just started to look like modern Australia. No grass, but lots of flowers and lots of fern trees and things like that. So
pretty lush habitat for a Savanosaurus.
Yeah, it would have been, and that's if you're a big animal, especially a big herbivore, you want a lush environment. You don't want to have to be travelling a long way to just eat a couple of bushes. So it would have been a very lush environment.
Compared to where they were found, it's quite a different climate.
Yeah, and that just shows you how much Australia has dried out. The other thing that happens during an ice age is all the world's water gets trapped in the ice, and the southern continents dry out. In fact, in the southern hemisphere, we don't call the ice age, we call it the big dry, because it dried everything out. So just at the dinosaur age, it would have been a lovely place, but then the planet started to cool, ice started to grow, the continent would have dried out completely.
Lastly, how does the Savanosaurus discovery challenge previous notions of the origins of sauropods in Australia?
Well, the weird thing about the titanosaurs is that they're some of the most primitive of the sauropods. So it's very interesting to find these right at the end of the dinosaur age. And what that tells us is that we didn't get more advanced species because there was no reason for them. Evolution wasn't really pushing them forward. What I'm trying to say is the more primitive species would have all originated from the one place, and that was when all the continents were joined together. And as these continents separated, individual species would then start to evolve and adapt to those individual environments. So the fact that there were very primitive sauropods in Australia shows how linked they were right back at the beginning to all the other sauropods, and yet they'd gone on their own path. They'd managed to survive in Australia, where the rest of the world they'd either changed or just died out.
I think there are implications in Dr. Stephen Poropat's paper for migration of dinosaurs from South America. Do you know much about that?
Well, we do know, and it also comes back to marsupials as well. There was a lot of migrating from South America across Antarctica and into Australia. And so because titanosaurs are a southern hemisphere group, they're one of the most primitive. And as I said before, like Argentinosaurus was the biggest of those. It's showing us how all these dinosaurs were a southern hemisphere group all joined together, and as they started to separate, they then started to evolve into their own slightly different species. And as I said before, marsupials did the same things. Marsupials did not evolve in Australia. In fact, the oldest marsupial fossils are from China. Then they crossed over into North America, travelled down into South America, then across Antarctica into into Australia, and they only just got here about 30 million years ago. So the marsupials only just managed to get into Australia before Australia rifted away from Antarctica. So we have a long history of getting our animals from South America.
Okay, so the theory is that Australian sauropods originally came from South America.
Yeah, although with this discovery of the prosauropod that we've possibly found up in North Queensland, possibly it could be showing the other way, that they evolved in Australia and then moved over to South America if the oldest ancestors of them are actually found in Australia. So the strangeness of Savanosaurus and its relationship to South America, we're talking about a lot of time here, nearly 100 million years. So perhaps the prosauropod that was found in Australia, they evolved in Australia, then separated, then travelled over to South America, where they evolved into and adapted to those conditions and turned into the titanosaurs, and then spent a couple of million years travelling all the way back. So perhaps we've got a boomerang species where these dinosaurs evolved in Australia, left, and came back again.
So that it hasn't actually been settled yet exactly what happened. It's all sort of theoretical at the moment.
That's the exact story of paleontology. Almost nothing's ever settled. It's the best answer we've got at the time.
That was Barry McKay speaking with Phil Hore about Savanosaurus. We'll hear more interviews from Barry about Australia's newest dinosaur and what it's like to dig for dinosaurs over the next couple of weeks. That's all from us this week on Diffusion. A big thank you to Andrew from Melbourne for his monthly donation. Send your contributions, opinions, congratulations, standing ovations, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com, and please do send me an email so I know you're listening and you'd like to hear more episodes. Please like the Diffusion Science Radio page on Facebook and rate us on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. Checking production this week was Charles Willock. I produce Diffusion, which is broadcast around Australia on the Community Radio Network, including 8CCC in Alice Springs and Tennant Creek, 2 MVR in Nambucca Valley, and 3 MBR in the Mallee Border districts of Victoria and South Australia. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, then you can explore more than 850 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.